All right, I don't have a whole lot for you today. We just have peptide bonding up on the board. I think we've only mentioned it in class, and maybe we've pointed it out just once. But when you go all the way back to, I would say, October, was that maybe about the first time you heard Markovnikov's rule? I don't know specifically, okay? So I think going forward from that, anytime we looked at organic reactions, and this is no different, even though this is your biochemistry section rather than the organic portion, you probably have heard this double-digit times. It's all about the what? It's all about the water, whether you are adding it or whether you are removing it, okay? So upon doing this, we'll just start over here. And it's not that you need to write this down because you've done this multiple times. And if you feel more comfortable doing so, that's, of course, fine. And again, it's just habit. Those unshared pair of the electrons are up there, 2 hydrogen bonds. And then this is what part of the structure, without going any further? This is what part of the structure? Starts with an A. You're going to hit yourself in the head and say, God, I knew that. Okay, well, let's go a little further. Because now when you look at this, okay, you have a what side and a what side now. This hopefully really clarifies things. So this is what side of the compound? Oops. COOH means what? Well, don't say it like a question.
Acidic side.
Yeah, the acid side, okay? So then that means this is which side then? Because these are all the same base structures. This, we haven't changed anything. That's one of these already too. The simplest form of these. So this whole thing is now called a what? Something acid. Yeah, so this is your amino side, okay? So when we form peptide bonds, which amino acid is that? Are you sure? Yeah, it's glycine. Yeah, I just wanted to be sure. Okay. Then you could put a methyl group on there. Okay. We're just going right down the line. Alanine. Okay. Then valine. Okay. Then we would have to switch the structure up a little bit. And this, from the organic portion, is a what type of derivative? It's 3 carbons. There's your clue. A little more specific when you say propyl. Yeah, it's an isopropyl group. Okay. And then, okay, I don't know how this purple's showing up. I see we got a big glare there, so you just kind of have to do our best. Okay. Then moving forward. Okay. 1, well, we'll call that one 1. So 2 or 3? Pick a number. Okay? So the clue to keep this one separate from this one was alphabetical order. So then this is which amino acid? It is isoleucine, because then when you move that down 1, okay, it's no longer isoleucine, but rather, yeah, leucine then. All right. Then let's see here. If we shorten this up, Okay? You're saying it. pH. Phenylalanine. That's right. Okay? And then, let's see here. Then I think it's CH2, CH2. Okay? That's one of the most important. Not that any amino acid is more important than the other, but this one, okay, would be what? Because it's the starter codon for RNA polymerase. Starts with an M. Methionine, that's right. Okay. Then I think that did it for all of that page. And then if we do this one, okay, it's very relaxing, and we say something. Serine, that's right. Okay. Then if we take that one off, and then if we put another carbon on there, and I'm pretty sure that is the next one. No, that's not right. That's what I meant to do. Okay? Yes, that is cysteine. That's right. Okay? And then, okay, we had this one up earlier. That's where I had goofed. I had put that down there. I should have left it up here. Then this is the next one. Starts with a T, I think. Threonine. That's right. Then, let's see here. We're winding down here pretty quick. And with that, depending upon how you want that bonded on there. Okay, so just like this is an acid side, this is also an acid because we have COOH, aspartic acid, that's right. And then should you know what aspartic acid is, you would know what glutamic acid is then. Even though that's not one that was required for you to know. Oh, okay. All right. Glutamic acid. All right. Yeah, I do have a star in here now that I think about it. Okay. I'm thinking of asparagine or asparagine, however you pronounce that, with glutamine. That's where we're making our mistake. Okay. And then your last one, of course, would be, oops, still have to put a bond in there. Got to take that off, put a nitrogen on there. Okay. Then this would be the last one that was on your list. Okay. Asparagine. Okay. And with that, again, notice nitrogen's in column 5, so it wants 5 bonds. There's 1, 2, 3, 4, and then, of course, 5 there.
Do you have to write it like that, or can you write it on one, or like one on each side?
These hydrogens?
Yeah.
Yeah, you could do it like that. Okay. I mean, just so obviously you put them there. That's, of course, the main concept. Then, with all of those amino acids, okay, just go ahead and pick.
The nitrogen is double bonded or the carbon?
It's the nitrogen. Oh dear, I goofed. You are right. I was just seeing if anybody's paying attention. Okay. There we go. Okay. H2. Man, I really butchered this one. H2. I think it's carbon, then the nitrogen after that. Yes. Okay. So go ahead and pick one more amino acid.
Serine.
Okay? So if you're doing that, of course, how you would start that is this. Okay? And then carbon. And then I'm just going to write it like that. So we now have serine. So now we're going to form a peptide bond. So what happens between these two? Remember, it was way long ago, we said all about the water.
The OH comes off.
Okay? So just like you did when talking about the monosaccharides, it gets left behind. And what we mean by that, of course, was this. Of course, you have that oxygen. And if there's an OH there, and if there's an OH down here on this one gets left behind. So same concept here. What's on the left, through dehydration, okay, this gets stripped off of there. And then that's half the molecule. Where does the other half come from? OH was stripped off. Okay, so what's specifically on that nitrogen? Okay, and then how many of them do you take off then? Just one. That's right. That's right. Because then when you take one of them off, okay, these two form a bond, and then this is called a what bond then? I suppose typically I think the author still puts one of them hydrogens down there, I think, because there was two. One got stripped off of there because of dehydration. And when you link this carbon to that nitrogen, it's now called a what bond? Yeah, it's called a peptide bond. That's right. Okay, so that's what we'll be dealing with on Thursday when that next paper is assigned. It's just more practice of writing these amino acids out and forming different types of proteins now, because on your paper, you're drawing amino acids. It's once you form these peptide bonds between these amino acids, then you're starting to form proteins. All right, that's all I have. We'll catch up to you next time.